Hello everyone. In this lesson, we will continue to study the frequency domain analysis module for continuous system. We will learn another method of frequency domain analysis for continuous system, the orthogonal function decomposition of signal, including the concept of orthogonal signal and set of orthogonal functions, and orthogonal decomposition of signal. Let's start with the concept of orthogonal signal and set of orthogonal functions. But what is the orthogonality of two signals? For function phi1t and phi2t defined in the interval t1 to t2, if equation 1 is satisfied, namely the inner product of the two functions is 0, we can say that phi1t and phi2t are orthogonal in the interval t1 to t2. Well, what is the set of orthogonal functions? If there are n functions, phi1, phi2 to phi(n), they can form a set of functions. These functions satisfy equation 2 in the interval t1 to t2. Then we can say that the set of functions is called a set of orthogonal functions in the interval t1 to t2. If a set of complex function phi I satisfies equation 3 in the interval t1 to t2, the set of functions is called a set of orthogonal functions. In this equation, phi j asterisk is the conjugate complex function of phi j. It should be noted that here, the conjugate inner product of function phi I and phi j is 0. For example, set of trigonometric functions and set of virtual exponentials are two typical complete sets of orthogonal functions in the interval t0 to t0 plus t. Here, t is equal to 2 pi over omega. Now, let's look at orthogonal decomposition of signal. If there are n functions, phi1, phi2 to phi(n), they can form a space of orthogonal functions in the interval t1 to t2, or form a set of orthogonal functions. Then, any function ft can be approximated by a linear combination of n orthogonal functions, and can be expressed by equation 5 or equation 6. How to choose the coefficient Ci to minimize the error between ft and the approximate function in the interval t1 to t2. In general, the mean square value of the error is regarded as the smallest. You can say that you've got the best approximation. The coefficient Ci is expressed by equation 7, where kj is represented by equation 8. The more terms you take, the bigger n is, and the smaller the mean square error is. As n goes to infinity, the mean square error is 0. Then equation 9 is proved. This is Parseval equation you learned before, also called the energy equation. To sum up, today we have learned orthogonal signal and decomposition of orthogonal functions. This class is over. Thanks for your listening. Goodbye.